The Natural Resources Conservation Service is the primary federal agency that works with private landowners to help them conserve, maintain, and improve their natural resources. The agency emphasizes voluntary, science based conservation, technical assistance, partnerships, incentive based programs, and cooperative problem solving at the community level. This year, they are really focusing on the soil health issue due to the drought that we are suffering.
No-till soils will recover from drought quicker than soils that have been tilled. That's the belief of soils engineer Paul Yassa with the University of Nebraska. He explains that no-tilled soils are able to absorb moisture better and faster than soils that have been worked.
So I want to park the tillage tools, build a soil structure that lets that water soak in where it lands, and then I get a more uniform water across the field. I don't want the hillsides running off and watering my bottoms. I want water everywhere so crop grows everywhere.
Tillage also destroys useful residue, which protects the soil from sun and wind that can evaporate valuable moisture. Finally, tillage forms a soil crust and damages soil structure. Yassa explains moisture finds it hard to soak in and is more apt to run off with tillage.
So by parking the tillage tools and leaving residue out there to protect that soil surface, then I can reduce that crusting, I can reduce the evaporation, I can reduce that runoff.
Yassa says even in winter, no-till fields are better able to absorb moisture as snows melt from the bottom up.
The no-till fields, the snow drifts sort of disappear. They're melting from the bottom, that water's soaking in again, giving us more water. On the tilled fields, it's frozen down below because the ground is dense. The heat can't come up. The sunlight's melting the snow from the top. It runs off.
Rebuilding soil moisture is key to a successful crop this year, but eliminating tillage will also be crucial. Yassa says even when excess moisture returns, no-till can grow the extra water out of the soil profile.
I want to have a crop growing there when my water is there. Now, with that in mind, I look at cover crops in wet years especially, that rather than till the soil or set myself up to lose water, why not grow it in a biological form that adds to the soil life?
I'm Pam Geppert reporting for the South Dakota No-Till Association.
My name is Jeff Hemingway. I'm the soil quality specialist here in South Dakota, and today we're going to actually go through our soil tabletop expo model. Really, the model is really designed to do just this: is that really look at infiltration and macropore development among soils with different management scenarios, and it's a very simple model to run. We really like to do this model because of its simplicity. But let me show you what we're talking about. First of all, this is our soil cutter. A 4-inch deep soil cutter. We can drive that into any field. You drive it down flush to the soil surface and then take a shovel or spade and actually remove the sample, slice it off along the bottom. So it's a fairly simple sample to pull. In addition to that, we actually have a no-till field that we actually cut a 4-inch sample out of. This field has been in no-till for 14 years in a corn, soybean, wheat rotation. In fact, we had wheat on it last year. It had a cover crop planted on it. And you can see the surface residues. You can also see, and we'll turn this over a little bit here so we can actually see the base. You can actually see that the soil is exposed on the bottom. You can see that we actually have some really good soil structure. You can see that we have some macropores that are exposed. We know that macropores are wormholes, those kinds of biological activity. Really pretty good looking soil sample. Let's put that back down here and take a look at our conventionally tilled sample. Okay, as we take this apart and we look at our conventionally tilled soil sample, what I mean by that is that this field was actually in no-till a number of years ago, and now it's actually been tilled up the last couple of years. We can actually see that by looking at this soil sample. One of the striking differences you can actually see here is that there's very little to no surface residues on this sample, and I'd like to flip this one over for you a little bit more, but the soil is fairly loose on the surface, but I don't know if you can see that. But as we start looking at the base of this sample, it has a very poor structure associated with the soil in the surface. So that, like I say, the whole idea behind this model is to look at water that is either infiltrating or running off soils, the same soil in this particular case, different management scenarios. We'll just put it back together here, and the whole idea about the model is its simplicity. You can actually see that it's designed that we're actually going to, in the sprinkler system here, you can see that there's holes in this tray above. We're going to actually move water back through that profile, sprinkle water onto the sample, have it either run off or infiltrate. Okay, let's just add water and see what happens. Okay, one of the first things we actually really notice is the amount of runoff and the very drastic amount, not just the amount of runoff, but the sediment that's associated with the runoff coming off these samples. You can see here that this sample has very little runoff coming off it at all. And this one actually has quite a bit of runoff. This is our conventionally tilled. Because that surface residue is not protecting that soil surface, we end up with that process of detachment and transport of eroded sediments. That's that water erosion process. Very visual in this particular case, where we see that very little runoff actually occurred. We had a lot of that water being infiltrated through this sample, and over here we had most of that water actually ran off and carried soil sediment. When we start looking at that difference between here and here, it's just really striking. That no-till scenario, we not only had very well, frankly, very little to no sediment actually being transported off, and that water actually then was infiltrated through. We'll just take a look at that real quick here. These no-till sample here. As you can see, again, we talked about all that surface residue before, and if we turn over this sample and look at the base of this sample, you can see that the bottom of the sample is very wet. Some major macropores where we actually have that water moving down through that soil profile. You can actually see some of those macropores, and that water is infiltrated through that soil and would move down in the lower profiles, being available for crop production. If you look at the tray, the catchment tray also, you can see that the amount of infiltrated water, 90% of it actually went through the soil sample and moved into the tray below, or would then have been moved into lower in the soil profile. Conversely, as we start really looking at our conventionally tilled sample, you can actually see here, first of all, the soil surface, of how puddled that soil surface is and how much sediment that's actually moved off. You can actually see that we have sediment still remaining up in our funnel. And of course, in our catchment tray, we end up with a lot of sediment that's come off this sample. If we look at the base of this sample, it's not wet at all. And in fact, if we start looking at this sample, you can see that we have dry soil clods. We had a little run over the side there. The water did not go through the soil profile at all. It's sealed off. And of course, that's pretty evident by looking at the amount of runoff we actually had up front also. So this is a really very simple, convenient model for us to use, mainly because it's very visual. It shows what we're talking about as far as macropore development, aggregate stability, and surface residues, how they interact to really affect the amount of runoff and erosion we have on our landscapes. So again, we really like this model, very visual, and it's a lot of fun to run this one.